Good morning. Thank you for logging into week 2. Today we're going to look at the test review. We're not going to give you all the answers or work them for you, but what I am going to do is go through each one or each type of problem and kind of give you a hint or a jumping board to get started. And it won't take too long, but I want you to at least have somewhere to get started. So if you're just lost and you're not figuring it out, that you can have something to see what they might look like. Also, don't forget we have office hours on Tuesdays and Thursdays. We also have from 8 o'clock to 12 o'clock. We also have a test this week on Friday, 2 assignments due, and a discussion due on Wednesday. So make sure you're really working on those. And then once I post this test review, you can start working on that test review, which is also due later this week. Make sure you're checking Blackboard for all the announcements or anything coming up. And let's get started. So we're looking at this first exponent. We're looking at the laws of exponents. Pretty much this whole thing is going to be laws of exponents. Basically, it's just a basic identity. If you've got an x with 2 exponents, and those x's are being multiplied, we know that we add the exponents. So it's kind of like doing one step simpler. And you'll see that later when we do the power rule. This is the product rule because it's 2 exponents multiplied. But later when we do the power rule, it always just makes it one step simpler. So like division, it's a real similar formula. You've got it. I'm going to leave it. You got x to the a minus divided by x to the b. And then you take the 2 exponents, and instead of adding them, it's kind of like one step simpler than division. X to the a minus b. Not too crazy. I'll let you work those. We're looking at number 5. Now it gets a little more complicated because we've got a power of a power, which is like 2 steps of power. So what we do with that, if anytime you got an x to the a power, that's a power, and then you raise that whole thing, so that's the power of a power. What we're going to do is we're going to make it one step simpler. So what's one step simpler than exponents? Multiplication. X to the a times b. Cool. That should be all you need. I might make a quick note for something like number 6 that you should know and what x to the 0th is every time. And that's a property that 100 to the 0th is the same thing. 4 to the 0th, so they're all going to give you the same answer. I'll let you discover what that is. There's a lot of resources you have to discover that, but everything to the 0th is going to be the exact same thing. There's your hint for 6. All right, so that looks like page 1. Page 2 is some solutions. 1 looks doable, 2 looks doable. 12, I'll give you a little hint. We're going to distribute twice first. That's where I see a lot of the most mistakes. Distribute twice. And the nice thing is you don't have to worry about a negative distribution. But on the next one, here's your little hint. Star, star, star. This is where people get tripped up. So if you need help with it, come and ask for it. We'll be happy to work it. But we've got a negative distribution. And that would be the hardest part to me. Negative distribution would be the part that I would see people really worried about or struggling with. All right, let's see what else we got. Solve the equation for the variable y. So you're just going to solving an equation for a variable. Another way to write that's a little like neater or easier for your to wrap your brain around is isolate y or get y by itself. So you're not necessarily going to get a number in that one. You're just going to get a formula to get y by itself. Oh, the same thing with the next one. The next one's get h by itself. I'll let you read the word problems all by yourself. And then let's look at these. Evaluate. Ooh, evaluate is a big word that just means plug and chug. If you've heard that before, or substitute it in, or plug the x in every time you see x. Not just one time, but every time. So if you see x equals 4 here, we're going to take that 4, and we're going to plug it into each of those x's. And 4 is not too crazy, but when we get to, number 21 looks like it's got a negative number. When we get to that negative number, here's what I would do. And actually, you can do this with the positive numbers too. Anytime you're plugging it in, use parentheses. So I'm going to star, star, star. Use parentheses. Every time use parentheses. So I'll show you. Whenever you're plugging it in, I'm going to rewrite the equation. Negative. Oh, I see an x. So instead of that x, I'm going to write parentheses. And then I'm just going to write whatever I see in the thing. Negative 2 squared. Minus 4. Oh, there's another x. Parentheses. Negative 2 plus 9. And then I'm going to work that out with my order of operations, my PEMDAS. I'll write that as a note. And if you're struggling with any of these notes and you're like, oh, I don't know what PEMDAS means, come to office hours. We are happy to work through it with you. We want to help you, but we want you to try it on your own. We're not. It's easy for us to give you the answers. It's a little harder for you to work it on your own. Let's see. Add x. Nope. That looks super doable. If you know what combining like terms are, here can be, oh, this is a good note for this. Combining like terms. And then the real question is, what's a like term? This is a lot of, I asked this yesterday in class, and a lot of students were like, it's something that looks the same. Well, yeah, but what is it? And they're like, oh, you can combine them. I'm like, yeah, that's what we're saying, combining like. So what is a like term? The definition really matters. It's a term with the same variable and same exponent. Now the coefficient doesn't have to be the same. The sign, positive or negative, doesn't have to be the same. But the variable has to be exactly the same, and the exponent has to be exactly the same before you can combine them. Cool? Same thing with the next one. I'll give you a little note. Star, star, star. Negative distribution is the toughest part. Negative distribution. And if you need practice with that, let us know. I'll literally go find a printout with 100 negative distribution problems. We can just practice them over and over. Because it does get tougher. Same exact note. Look, I'm going to draw an arrow. Exact same note right there. All right, factor. I'll keep going in order, and then I'll hop over to 30. Foil or box. Watch that video. Foil or box. I don't mind which one. I like both. They're both good. Same thing here. Foil or box. And there's a little trickiness to it because it's like, whoa, I don't see what to foil. If you really think about what exponents mean, you might see that. Okay. Oh, this is the last page. This will be a short video today. Divide. Give you a little hint. Looking at common terms. Looking at what terms they have in common. And then on top of that, so you're looking at what terms each of the top terms have in common with the bottom. And then on top of that, you're remembering this property of fractions that says that I'll use ABC and I'll use Z for the bottom. So that A plus B plus C over Z, no matter what those letters are, those letters could stand for a billion different things. But A something plus something plus something divided by some random thing is the exact same thing. This is the laws of fractions. This is the law of the sums of fractions, where you can split them up. And then you can work the problem, and hopefully that makes it a little easier to work. Hopefully then we can go back to the quotient rule and use that. Cool? Let's see. Factor, factor. You got that. Perfect square. Perfect square. I like that note for 29. Okay. So you got factor, factor. Oh, just a whole row of factoring. That's awesome. That's really good to practice. Just a note for factoring, I guess, because it is important. Don't forget to break up that last term into all of the factors or multiples of that. Multiples? Yeah, multiples of that term. So 6 turns into 1 and 6, 2 and 3, and that's really it. So don't forget to break it into all those multiples and see which ones add up to give. Oh, I did miss one. I missed 2. -1, -6, -2, -3. There we go. Which ones add up to give you the middle term, which is also in our formula, the B term. The middle term, which is B, in the ax squared plus bx plus c. Ax squared plus bx plus c. The standard form of a quadratic equation. Okay, factor, factor, factor. Ooh, you got a little bit of tough factoring on the end when it has a coefficient in the front. So when it gets a little bit tougher like that and it's got a coefficient in the front, don't forget about this thing. It's called slide, where you take that over and then you're going to end up dividing back out that 2 at the end. It's like slide and divide. I don't remember. I know it's in your book, and I know you can go through and work these problems and learn it, but I might just do one of these just so we can kind of see what it looks like, if that's okay with y'all. So, as a free review question that you're getting for free right here. So what I was saying with that slide is we multiply that 2 times that 3 on the ends, and we end up with x squared, because it goes away. We're sliding it over. We're not just multiplying it and leaving it. We're sliding it to the end, plus 7x plus 6, because 2 times 3, this arrow stands for multiplication. 2 times 3. We're doing the front and the back, sliding it over. Then we're going to factor that normal style. 6 turns into 1, 6, 2, 3, -2, -3, -1, -6. And our brain's got to ask ourselves, which of those 4 sets of terms combine to give me the b? So 1 and 6 give me 7. Oh, that's it. But let's check the rest. 2 and 3 give me 5. No. -2, -3, that's -5. No. -1 and -6, that's -7. No. Here, I can write those there so you can see that. So that 7's the good one, right? So there's our terms. We're done, right? We're done with the factor step. Now we have this divide. We have the slide and then the divide, but it's important to know we're almost done with that factor step. So we're going to go, and we are going to write x plus 1, x plus 6, right? All right. But we did this thing at the beginning that we can't ignore. So it's not okay to end there. If you were to box method that, it wouldn't give you 2x plus 7x plus 3, right? It'd be silly. Like, no, it'd give you x squared plus 7x plus 6. So we got to do something else, right? That's where the divide comes in. This is the divide step. We're going to now take that 2 that we moved over to the end and divide it. Boop, boop. Everybody okay with that? So now what we're left with is x plus 1, okay? And x plus 3, because 6 over 2 is 3. I just reduced that. Oh, 1/2. I'm so sorry. You were probably screaming in the camera saying, whoa, no, you forgot your 1/2. X plus 1/2 and x plus 3. Okay? And now the last step is anytime you've got a denominator left over, I've got a denominator right there left over, what you're going to do is you're going to reslide. So it really should be slide, divide, and then perhaps, not every time, it won't always happen. So you slide it over to the end, you divide it out in the middle, and then you're going to slide it back over if it stays on the bottom. So that 2 gets to slide back over to the front and get canceled out. So now we're left with 2x plus 1, x plus 3. There's just a quick example of slide and divide. There's a couple other ways you can do the same exact thing. It's doing the exact same steps and a few different looking at it. So if you learned it a different way, that's okay. But I think slide, divide, and then on this one we had to reslide that 2 over is the quickest way to make that happen. Okay, good example. So you might have to do that with some of these other ones as well, which is A-okay. All right? Looks good. I don't see anything too crazy. If you need to just watch this video and pause it for each example, that's okay. If you need help with some of these word problems, that way we don't have to just read them and bore you with the reading, you can come to class, come to office hours. I'd be happy to work some word problems with y'all. Thanks for watching. Don't forget 2 assignments this week, then a discussion that's due on Wednesday, then the test review is due for a grade. I don't remember the day, but it's posted right under the test review. Look at which day it's due. I can't remember if it's the day before or the day of the test. And then feel free to reach out via email. Some of you already have. To make sure that you're submitting all your assignments on time and prepared for this test coming up, because it's going to be really important. So have a good week. If you have any questions, feel free to reach out to me or Dr. Solis, and we'd be happy to